Hello everyone, and welcome back to another video about IB Math. In today's lesson, we will be studying differential equations that can be done or solved by integrating factor. This is a topic in the IB Math AA high level. Now, before we start this topic, I recommend that you are familiar with the product rule in differentiation and implicit differentiation that appear top right of the screen. So let's now start this. Here, as you see, this is the type of differential equation that needs solving by integrating factor. The standard form must be only like this. Here you have y prime or dy over dx plus pxy equals qx, where px and qx are functions of x. You must have only y prime by itself. It shouldn't be multiplied by anything, x or 2 or whatever. Otherwise, we need to divide by that to cancel it. Also keep in mind, you need to recognize it when you see it in questions because it cannot be done in a different way. As you know, in the IB, there are many types of differential equations like separable equations that need integrating factor or homogeneous differential equations. Here, you cannot separate x and y, so you cannot follow the separable method. And even you cannot do it, of course, as homogeneous because it's not homogeneous. So the only way to do it is integrating factor, which is given by this formula in the formula booklet. I will explain how to do these types of questions step by step. So here we have an example. Now notice that the existence of y prime or dy over dx plus another y indicates that it will be of this type. But here we have x. We said that we shouldn't have anything here. That's why I will divide here both sides by x. If I divide here both sides by x, here the x will be cancelled, but here the 3 will be 3 over x, and if you divide here by x, it will be x cubed in the denominator. So here it's ready now. It's written in this standard form where px is 3 over x. Now, after it's ready, the first step to solve equations like these is to find the integrating factor here. Let's name it I. So the integrating factor I will be, as you see, a, the integral of what? The integral of px, which is here 3 over x. So I will integrate 3 over x dx, which equals 2. Now we know that when we integrate 1 over x, it will be ln x. So when you integrate 3 over x, it will become 3 ln x. So here I will write 3 ln x. And we know from the properties of logs, the 3 can go up here on x, so it will be ln x cubed. Finally, e and ln cancel each other, so it will be x cubed. So this is the first step to find the integrating factor here, which is x cubed. After you find it, you multiply both sides of this standard equation by the integrating factor you have. So here we'll multiply both sides by x cubed. It will become, if I multiply it here, I will have x cubed times dy over dx. So here x cubed dy over dx. Plus, if you multiply this by x cubed, it will be 3x squared y equals, and this will be only cosine because the x cubed will cancel. So here, I've multiplied both sides by the integrating factor. Now the next step, which is the most important step in this method. After you multiply both sides by the integrating factor correctly, always the left-hand side can be regrouped or written like this: the derivative of something. The derivative of what? Always the derivative of the integrating factor you found, which is x cubed, multiplied by y, always y. So here again, if your work is correct, if your integrating factor is correct, always the left-hand side will be regrouped like this. The derivative of the integrating factor multiplied by y. And check, by the way, really, if you differentiate this multiplication between x cubed and y using the product rule and implicit differentiation, you have to get the same as the left-hand side here. You can check it. Now, the right side will be as it is, cosine x. So here, I rewrote this like this now, and now it's ready to integrate. Here, an optional step is that you can multiply both sides by dx. So here, if you multiply by dx, you will have d x cubed y equals cosine x dx. Now here, it's ready to integrate both sides. So now after we did it like this, we'll integrate the left side and the right side. Notice that here you have integration and d, or differentiation. Integration and differentiation cancel each other. They undo each other. So that's why we will always do it like this. Cancel this and this. You will have only x cubed y left. So here, x cubed times y equals the integral of cosine x is always sine x, as you know from the formula booklet, sine x plus the constant of integration c. Now we need to get y, not only x cubed y. So that's why to get y alone, I have to divide by x cubed. So here, y will be sine x divided by x cubed plus even the constant of integration will be divided by x cubed. So this is the general solution to this differential equation. I hope that you have found the video helpful. Please consider subscribing, and thank you for watching.